Hi everyone. In this particular video, we are going to cover third problem of Leetcode weekly contest 402. It was a wonderful problem. So let us just go through the problem statement. So problem statement is there is a magician and which who is going to have multiple various spells. And what is given is you are given an array and the name of array is power where each element represent the damage of spell. Okay. Multiple spells can have same damage. Makes sense. It is known fact that if magician decides to cast a spell with damage of power of I, means if he picks the I spell, then he cannot cast a spell with damage power of I minus 2, power of I minus 1, power of I plus 1 or power of I plus 2. Each spell can cast only once. So we can use any element of array only once. Return the maximum possible total damage that a magician can cast. Okay. So I'll explain you the problem statement. So you are given an array power. So which contains the power of every spell. Okay. Now what it is saying is we can take one of the examples. So one, 2, 3, 4, something like this is there. Okay. Now what you have to understand here is if a magician is casting this spell, so what is going to happen is, okay, first of all, what you want is maximum possible total damage that magician can cast. Basically, sum of value of all the spells that magician is casting. So suppose the magician is casting this spell. What is the value of this spell? 1. So now magician cannot cast any spell of value 0, minus 1, 2 and 3. Actually, let us see the constraint if negative values are there or not. So value of what I can say spells are positive only. So you don't care about the negative ones. Okay, I just took an example. So here these are irrelevant, but here these are relevant. It simply means, okay, if magician have casted a spell of value 1, then he cannot cast spell with value 2 and value 3. He have only option of casting spells with value 4 onwards. Okay, this is the crux. Okay, you need to focus on such points and observation. Next is okay, what are the constraints given? As you can see, the length of the array can be up to 10 to the power 5, and the spell values can be up to 10 to the power 9. Okay, these were the constraints. Now, that was the problem statement, and I hope you understood it. You have to find what is the maximum value you can cast. That is going to be the maximum total damage of spells you are going to cast. So in this case, the answer is going to be okay. One more observation here is before we find the answer for this particular case. If you cast a spell with value 1, then you can again cast a spell of same value, because there is restriction with value minus 1, value minus 2, value plus 1 and value plus 2, where value is nothing but the value of spell you are casting. Okay, so here you can cast these two spells with value 1. You cannot cast 2, you cannot cast spell with value 3, but you can cast a spell with value 4. So in that case, the total cost that you are going to get, or the maximum sorry, total damage that is you are going to get is 6. Okay, this is one of the options. There can be multiple options also. Suppose you cast a spell with value 2. In that case, you cannot cast a spell with value 1, cast a spell with value 3, and cast a spell with value 4. So you cannot cast any of these. In that case, your total damage is going to be of value 2. Similarly, if somebody or magician is going to cast a spell with value 3, then he cannot cast a spell with value 4, neither for value 2 and neither for value 1. Okay, so magician need to be very careful. Now, here, one thing you need to understand is you have choices with you. There are choices which spell you can cast. It depends totally on you or the magician. So, remember one thing, or Write it down. Whenever you have choices in problem, you are going to use recursion. Okay. Recursion is going to help you out, explore all the choices and give you the optimal solution or the value you are looking for. Okay. So remember, whenever there are choices in problem, you are going to use recursion in that case. Okay. Now, one thing which you need to understand here is what are the steps that are required for writing a recursive solution. Okay. I think the answer for above test case, if you're looking for it, is 6. 1, 1, 2, 3, 4. In this case, the answer is going to be 6. Okay. Before we jump to the recursive solution, why don't you try to find what is the maximum value or damage that you can that the magician can cast if he is going to have spells like this. I'll take a pause here. So, or you can pause the video here and find the solution. I hope you have done. Now, for this case, magician can cast spells with value 2, both of them. He will get 4 amount of damage. Then he cannot cast spells with value 3 and value 4. Okay. Now, if magician cast spells with value 3, then he is going to get all the threes. Like he will be able to cast all the spells with value 3. In that case, he will get 9. But he won't be able to cast spells with value 4 and 2. Okay. If magician cast a spell with value 4, he will get 4 only. So you have three options which you explode and the maximum out of them is 9. So the 9 is going to be the answer in this case. Okay. Now let us try to write a recursive solution for this. Okay. Steps for, okay. First you understood why we are writing recursive solution because we have multiple options or choices for us to make. Okay. Not make, like there are multiple choices which we want to explore and find the best one, best result for us. Now in this case, whenever you want to write a recursive solution, not in this case, in general case, whenever you want to write a recursive solution, you have to assume you are present at some random state. I don't know why I wrote I here. Let us go stepwise. So you have to assume you are present at some random state. Now, from that random state or in that random state, what all options you are going to have that you'll explore and you'll do what you can do in that case. If you just take care of that random state, then recursion is going to take care of all the remaining cases. That is the magic of recursion. Okay. Now, in this case, if you want to write a recursive solution, obviously, first observation which you can make is you have to go through all the spells, or before that, one more optimization which you can do in this case is as I took the previous example 2 2 3 3 3 4 was there, something like this. So here one thing that you can notice is okay, if there is an array like this also 2 4 2 3 2 sorry 3 3, I can have 3 here. I just rearranged all the elements of these array. In this case also answer is 9. You can cast spells with value 3. Okay. So one more thing which you can notice from here is the order of elements is not important. order of elements is not important because they are giving you same result. Your answer is not changing after changing the order. So whenever order is not important, always sort the array. So these are small things which makes a lot of difference. Okay. Now why sorting? Initially you won't be able to understand, okay, sorting is going to help or not. But in future you might be doing some operations on sorted array, and that is going to be much more efficient as compared to unsorted array. Okay. So whenever order of elements is not important, please sort it. So what you did is you have sorted the array. Next observation. So you have these array 2, 2, 3, 3, 3, 4. Okay, this array is there. Now, if you are picking, suppose 2, and suppose we have 5 or 6, suppose, let's take an example extending this array. So if you cast a spell with value 2, then what you are going to get is from this next spell that you can cast of different value is going to be 5. 5 onwards. You are going to skip all these values. Okay, even this too. Or what I can say, if there are multiple same values, it is beneficial for you to take all of them at once. Okay, and here you are doing a skip or jump of these many indexes. Okay, so now what point I want to make here is, why don't I convert this array into unique elements array which is arranged in sorted order? Unique elements array which is 2, 3, 4, 5, 6, and have or and store their frequency in map or hash map or dictionary. Map, hash map or dictionary. Why don't I do this? Why it is going to be useful for me? I'll cover this. Okay, this when you have unique elements, it will help you move to or skip same elements, because when you have same elements, if you cast a spell with value 2, it is good for you to take all the values, all the spells with value 2. So why you want to do the same number, or why you want to count them as different states? So I just want to compress my array, reduce the size of my array. Okay, why? Because whenever you are casting a spell with value 2, 3, suppose, so it is useful, or you are going to take all the spells with value 3. Okay, so when you compress them into unique elements array and maintain their frequency in map and hash map in one step only. Like here you have to have go to three steps. First you take this spell, next you take this spell, next you take this spell. So three steps you are following. Number of operations are increasing. Instead of that, what you can do is you can have a unique array 2, 3, 4, 5, and 6, and have the frequency of them stored in hash map or dictionary. Like hash map or dictionary are going to store details like this. 2 is occurring 2 times, 3 is occurring 3 times, 4 is occurring 1 times, and 5 is going to occur 1 times, 6 is going to occur 1 time. If we have something like this, if I'm picking or casting this spell, then obviously I'll take, or I will add this spell 3 times or cast this spell 3 times, because there are 3 spells with value 3. So in one step only I can find how much value I'm going to get by casting spell 3. You're going to get 3 into 3, which is 9 amount of value by just casting spell 3. Why? Because there are 3 spells with value 3. Here what happened? Number of operations are decreased. So you need to look for such optimizations. Such small things actually affect. Okay. Now, so what we are going to do is we are going to sort the array and we are going to maintain frequency. Let us do this step by step. So first things that we notice is sorting is going to be helpful because order is not important. I'll keep on writing and we'll keep on doing that in parallel. Sorting is important, or we are going to sort, I would say. We will sort the array as order is not important. Okay. So we are going to use sort function, power dot begin and power dot end. Now what I want to do is I want to create array of unique values. So let's have a dynamic array named as unique, and we will add the unique values. At the same time, what all I need, I want to maintain their frequency. Frequency in the sense how many times that particular element is occurring in your array. So we are going to use map in C++, which is same as dictionary, and hash map in Java and Python correspondingly. Okay, so the declaration of that is like this. Okay, now here what I want to do is I'm using long. Let us use long here also because we need to return the answer in long for C++. So there is a, you should not face any issue with the typecasting thing. So it's better to use all of same data type. Okay, or long, that will be helpful. So this is, let us name it as count. This will store the frequency of all the elements. Now how we are going to do this is, I'm showing you how you can create a unique array by just sorting them out. So I'll take a variable which is going to be current, which will store the current value of element that you are picking, which is equals to first element of your power array. Now you'll simply go through all the elements of the power array, or basically all the spells. Let us take the size n as input, not input. N is going to store the size of your power array. Now here, if your current value is equals to current spell value, or I should take this as what is the last spell that you took, what the value of the last spell that you took. If the last spell that you took is having the same value, then you don't need to add in your array. The whole goal of this particular technique is whenever you are getting a different value, you'll add the last spell value that you had in your unique array. Okay. Now you have to update your last also this time. Now take couple of minutes and try to understand what I did. I took a variable last, which I initialized with the very first element. The goal is very simple. I'll show here. So you have something like this: 2, 2, 3, 3, 3, 4, 5, 6. Something like this is there. So what you are going to do is you are going to take a variable last and you'll make it equal to the very first element. Now you compare, are they equal? Yes. So move on to next. Are they equal? Yes. So move on to next. Now 2 and 3 are not equal. So in your unique array, add 2. Okay. Next, you'll update last to 3. So now your last spell value is equals to 3. Now you go to the next, you compare, are they equal? Yes. So move on to next. Are they equal? Yes. Move on to next. Now 3 and 4 are not equal. So add 3 in your unique array. And this will continue. Eventually, when you'll finish it off, or let us do it for this case. So here last value is updated to 4. When you go to next element, 4 and 5 are not matching, so you'll add 4 and update your last value to 5. Similarly, next you go to 6 and 5 and 6 are not matching, so you'll add 5 and you'll update your last value to 6. Okay, now you'll try to go out of the array, so your iteration will be over. And now, are we done? No, we have to add this 6. That 6 is missing. So we are doing the same stuff. Okay. Whenever there is a mismatch, we are adding in our array and updating the last value. And when we are done, then also we have to add so that we don't miss out that 6. If you remember the example which we just took. Okay. Now the unique array is created. Now here only let us use the map for updating the count. So the syntax for that is this in C++. So what I am doing is this particular value, I am incrementing the count of this value. Okay. If this value is present, its count or value corresponding to this is going to be updated. If it is not present, it is going to add and the default value is going to be 1. Okay. So this line is going to update the count of all the values of array. So we are done with this part. So whatever we discussed, we sorted the array, we created a unique array to minimize the operations, and we maintain a map which is going to store count or frequency of all the elements present. Now we have to write a recursive function. Now we have to write a recursive function. Now let us try to write a recursive function. What we are expecting from recursive function, we want to find what is the maximum value we can get. Obviously you have to go through all the, I'll write everything. So what is expected from recursive solution? So we are expecting maximum value we can get. Now what else is there? We are going to go through all the spells. So our index is required, which spell value you are currently present at. And what else is required? We require spells array. Okay, so we are going to use the unique spells array. And don't bother with this reference. It is this and symbol. It is nothing but we are sending value by reference. That is usually increments or increases your or decreases your runtime because you are not creating any extra space. And what else is there? You want the frequency map that you created. Okay, these all three things you require. Okay, the name of that frequency array is equals to just a second, is count. Okay, maybe I can just increase this a bit. Yeah, sounds good. Okay, now whenever you are going through an array, you have option of going from left to right. Okay, so whenever you are going in an array from left to right, this base condition you can always use. Whenever your index is invalid, you can add a base condition there. So let us find what is the length of this unique array. And a base condition can be whenever your index is not valid or index I is greater than equals to n. So in that case, what is the maximum value you'll get? If your index is not valid, it is 0. I used LL because of typecasting. We have to return a long value. If I return 0, it will treat it as integer, which is also fine. Okay. Now here, what option you have? You have to consider yourself. You are present at some random index I. And trust me, you already have done majority of the part. If you look at this, these are the parameters. What are the parameters of your recursive function? Index, the spells array, which contains unique values, and the count map. Out of these three parameters, which all are changing, only one is changing, that is your index. Okay, so you have to assume whenever you are present at some random index I or some random spell I, you only have two options. You have two options. What two options you have? You have either you can pick or cast this ith spell or leave this ith spell. So you are going to get two values when you are going to cast and when you are going to not cast or leave, or I should use no cast. So when you're not casting this ith spell, it simply means you'll move on to next spell. Suppose we are moving from left to right. So we will move to next spell when we are not casting ith spell. We are going to use our recursive function. We'll go to the next spell and these are going to be the parameters. That's it. Trust me, you just have to do your task in proper manner and recursion will take care of all the remaining cases. Okay, now see here, when you are going to cast the ith spell, you are going to get this much value. Now try to understand what I'm writing here. I have done nothing. What I have done here is, if there is a spell with value 3, so I added this 3 value and stored in the cast variable that I took, that will store what is the total damage that I am going to get if I cast this particular spell. Okay, so cast value is going to be there. Suppose there are three spells or four spells with value 3. So in that case, that value is going to be multiplied. It is going to be 3 into 4. It will become 12. So that I am doing in this case. So here I am taking all the spells whose value is equals to unique of I. Okay. Here I had one spell, then I find out there can be multiple spells and the frequency is stored in my map. So this line 15 is very important. This will make sure I am taking all the spells whose value is equals to unique I. That's all. So if there is a spell whose value is 3 and frequency or number of times it is occurring is 4, then cast is going to be equals to 3 into 4, which is 12. Obviously you'll cast all the four spells and you'll get value 12. Okay, so those four things are happening. Now here, tell me one thing. If I'm casting a spell with value 3, now which spell value or spell can I cast next? Obviously I'll not move backward because I'm moving from left to right. I have to move ahead. So I can cast spells with value 6 onwards. Did you understood this? If there is any spell which is having value greater than 5, I will be able to cast. After casting spell with value 3, because it is mentioned in the problem statement here, it is mentioned if you cast a value with power I, you cannot cast a value with power I plus 1 or power I plus 2. Okay. Now you might ask, okay, why I'm not taking that into consideration? This power I minus 2 and I minus 1, we are not going back. Okay, so think like this: if you have an array whose values are 3, 4, 6, 7, and 9, suppose something like this is there. if you cast a spell with value 3, next you can cast is a spell with value 6 onwards. You can cast 6, 7 or 9. Okay. So you'll go to 6. Now try to understand this. When you are present at this point, if you cast a spell with value 6, you can cast next spell with value 9 onwards. Okay. So remember, when you are at 6, where you came from? You came from 3. So you already skipped 4 and 5, which was the case. If you cast a spell with value 6, you cannot cast a spell with value 4 or 5 or 7 or 8. So this part is already skipped. We are going from 3 to 6, then 6 to 9. So all those conditions are going to be taken care of. So now we just need to find index such that the value is greater than 5. What is 5 here? Current value plus 2. Okay, we cannot cast any value which is equals to or up to 5, or in the sense I am saying any value which is smaller than 5 or smaller or equal to 5, because I am at 3, I cannot cast 4 and I cannot cast 5 also because of the condition, this condition which is mentioned. So here, for quickly finding, if you remember we sorted the array at the beginning, we can use binary search for finding the index of next spell that we can cast. So let us use the function. We need to create a function. It is going to return us the index of next spell that we can cast. Let us name it as search, the function name, where we will pass our spells array and what value, and from, so okay, so if you are present at index I, you have to look beyond index I. You have to look from I plus 1 to n minus 1. This is the range. Okay, because you already have casted all the values of index I. Now option remaining is I plus 1 onwards. So I plus 1 I have to pass because this is going to be a starting onwards, starting index. From where onwards you will try to find the value, and what value you are looking for? This value. Any value which is going to be greater than this. Okay. Or to make it more simpler to you, any value which is equals to this, greater or equals to this. I can say greater equals to 6 also. Does this make sense? Either you can write greater than 5 or greater equals to 6. Anything you can do. Now we just have to write the function, search function, where we are going to get array as one of the parameter, and what index we are going to start from and what value we are targeting. Okay, ending index is going to be the very last valid index, which is length minus 1, and mid index is always is equals to start plus end by 2. Let us take answer to be minus 1. This is answer is going to be the index where you can start casting, or the next spell index which you can cast. Okay, minus 1 simply means like what if there is no such index? So we are assuming there is no such index at the moment. If we find any index while doing binary search, we will update. Okay, we have to return the answer. Now what are the steps of binary search? Your starting index should be less than or equals to end. What is the condition here? If the element at mid index is greater or equal to the value that we are looking for. Like in case of 3, this value is 6. So if there is any value which is greater than equal to 6, you can cast that. Okay, but we are looking for, so there can be multiple options. If we have 6 also, 7 also, 9 also, where I want to go to 6. I can go to 7 and 9 also, but I'll go to 6. 6 is the smallest valid spell that I can cast. So what you'll do here is you will consider this index and look for smaller one. Look for smaller one because you want to find the smallest valid index, the index of smallest valid spell which you can cast. Okay. So for reducing, you have to update your end to mid minus one. Like whenever you want to look for smaller values, you have to update your end. Whenever you want to look for bigger values, you have to update your start to mid plus one. That's it. Now you have to find the mid value, which is start plus end by two. That's it. So we are done with our binary search function. So this is going to give us the index. Okay. Now if index is minus one, if index not equals to minus 1, let us say like that. If index not equals to minus 1, it means there is a valid index where we can go to, or there is a valid spell which we can cast. So we will use the recursive function for going there and finding what is the maximum damage we can get from there. Okay, so it is going to be cast plus equals to, we are going to use our recursive function maximum value, and we will go to that index, and these are going to be the parameters. Okay, now we have two options, two values we are getting. One, when we are casting we'll get some value, when we are not casting we'll get some value. Okay, now which value we are interested in, we want to find the maximum out of these two. So maximum we'll get from not casting the ith spell and casting the ith spell, we want to return the maximum. That's it, we are done with our recursive function. You can take pause or rewind the video if any part is not clear. Here the spelling mistake is there. Index. Let's try to run this. Okay, non-void function does not return a value. So we are not returning. Okay, we need to return something. We declared the recursive function which will find the maximum value for us. We can return that. We have this max value function which we will call. We'll start from the 0th index, we will pass the unique array and our count map that we created, and whatever value we'll get from there we are going to return that. Okay, let's see if it is working or not. Cannot bind value of okay, what is the issue here is it is pointing out we have a vector of long long, maybe we declared int here. Yeah, that is issue here. So we need to change this to long long, and here also maybe we need to change this to long long. It is simplest way, like when you don't want to do typecasting. Okay, so it is passing the test cases. I hope you understood. Let us try to submit this. It is going to give DLE, okay, as expected. The reason is the time complexity of our recursive function in worst case is not linear, it is exponential. Simple words, what you can understand is two options are there, and we have n options, so that is 2 to the power n, plus it is going to have this binary search which is going to take order of log n. So the time complexity comes out to be 2 to the power n into log of n, which is a very big value because your array can be very large. Array can have up to 1 lakh elements. Okay, so that is causing an issue. So whenever you have something like this, use memoization. Simplest way of using or memoization is nothing but using an array, or you can use map also. Memoization is nothing but storing the result and using it. Storing the result and using it. So whenever we are, there are only n different states, because how many variables are changing, only one variable is changing, that is index I. So there are only n different states. Whenever we are finding result for them, if we'll store them and use it in future, that will reduce our time complexity by a lot. Okay, now we can use array for memoization usually. So I'm going to create a array named as dp. Why dp? Because memoization, recursion plus memoization is known as dynamic programming. That's why. So index value can be up to 10 to the power 5 minus 1. So you can create an global array of that big size. So I have created 10 to the power 5 plus 1 size array. Now what are the steps of memoization is, so you will use the result. You will first check, okay, I should write like this. First, I need to zoom in a bit. So first, check if you have result or not. Check if you have result or not. If result is there, if result is there, so usually what we do is we fill our memoization array with some default value. Steps of memoization are simple. We fill our memoization array with default value. Here we are filling with minus 1 because the power cannot be negative at any point. The least you're going to have the power is 0 when you're not using any spell. So if it is not equals to default value, so it means you already have calculated the result, you are returning the result. Else what you are going to do is, before returning, you will store that result. So here you are storing the result, then you are returning the result. That's it. So your memoization part is done. Now, whenever before calling this function, your task is, there is only one task: fill the memoization array with default value, which is minus 1 we are taking in this case. In C++, we have this function memset, which is used for actually filling a static arrays, and this is the syntax for that. Okay. So now our code is memoized. We are not going to compute same subproblems again and again. Okay. Now let us try to run on this test case where we got time complexity. And what is going to be the memoized time complexity I want from your end? Okay. Now it is passing in 0 seconds. Let us try to submit this, and it is accepted. Okay. So that's all from my end for this particular problem. If you have any difficulty in any part, uh, you are free to comment down. Even in Discord, also, you can ask your doubts regarding this. If any part is not clear, you can rewind and check it. Okay, that's all. Thank you.